All right, so this is a full paper that we are going to consider, our mathematics paper 2, which was written in November 2023. So we are going to consider this question paper. Make sure that you go through the instructions whenever you are to answer your final examinations. The instructions that you're given, they are very, very important. So in this case, considering that you're supposed to answer all the questions in section A and any form, which is in section B, and mostly about the working that you're supposed to show clearly the working, and also omission of essential working will result in loss of marks. So this is paper 2. What is important is the working that you're going to present. Make sure that everything is presented. That is important. All the steps, they are presented. And also, if the degree of accuracy is not specified in this question, and if the answer is not exact, like you're given those decimals, endless decimals, on that condition, you are supposed to round off correct to 3 significant figures. Then for the angles, you use 1 decimal place. So that is what we had. We are going to go through our question and see what we are given so that we'll be able to understand how to answer these typical questions in a future examination that you're going to have. So considering other revisions, do make sure that you contact +2761864 4043 so that you'll be able to be added in the WhatsApp group for other questions that you might be able to send. And also make sure that you do yourself a favor to subscribe to the Maison TV, which is the other channel that we are going to be focusing with in our revisions. So it can be a daily revision that you're going to have from them. So make sure that you become part of this. Just search this part, then you will be able to subscribe them, and you are now part of their family. As we are going to be having the revisions, you will make sure that you do not miss any of these. All right, so this is section A. Answer all questions in this section. Number 1A, item 1. The price of a packet of sweets was $1.20. So this was $1.20. And we are given the price increased. So, okay, before that, it was this price, meaning to say that is the original price was. That is, initially, we had this price. Originally, this is what we had, was. Before anything happened, it was at this price. So this is our original price. Then the price now increased to $1.50. Calculate the percentage increase. So there we need the percentage increase. So given that originally we are given that it was at $1.20, then it increased to $1.50. So the increase is simply the difference. Before we talk about the percentage, what is the increase? The increase is going to be the difference that we have from the amount which was increased to this amount. That is, now it is costing $1.50. This is the price now. So meaning to say the increase is going to be the difference that you're going to have of $1.50 minus the original price that we used to buy a packet of sweets, which is at $1.20. So the difference there is the increase. So this is paper 2. Do not worry about this. Just use your calculator. You're going to obtain 0.3. So just indicating that this is money, you can just indicate another 0 to indicate 2 decimal places. So this is the increase, not the percentage. So in order for you to have the percentage increase now, for you to have the percentage increase, it is the increase that you have of 0.30, which is just 0.3, over the original price that you had of 1.20, which is same as 1.2 times 100%. Remember to convert to a percentage, multiplying by 100%. Like I said, this is paper 2, everything on your calculator. you are going to obtain 25%. So when they're saying omission of essential working, it is to show that you are subtracting, you're just writing the answer 0.3. You are not showing where the 0.3 is from. You just write increase is equal to 0.3. To show that you're subtracting and the answer is enough. This part of a percentage to show this is paper 2, it is enough. Then you press your calculator, you have got the answer. So that is the idea there. All right. So this is what we're supposed to have. And item 2, we are given, that is a new cereal pack contains 20% more. Take note there. It contains 20% more. That is an increase from what it was before. It now contains 20% more. Okay, from which percentage? That is the question. If it is going to have 20% more, from which percentage? I said, originally, the percentage before any increase that you are going to have, it must be at 100%. At an original condition, you must be at 100%. Whenever I talk about the percentage, you must be at 100%. This is the original part that you're given, which is the original value. So they are saying a new cereal pack, it contains 20% more cereal than the old packet. 20% more. If it was at 100% originally, then there's a 20% more. It means we are going to add. Of the 100%, we add 20. That means we are now at 120%. So at 120%, they are saying if the new packet now, which is the new packet which has been increased, it now has a mass of 264 grams, meaning to say at 120%, it is at 264 grams. Calculate the mass of the cereal in the old packet before the increase at 100%. Remember, I said originally you are at what? You are at 100%. This is the old package that we had. Then this is the new package after an increase. So if they said you're considering a decrease, you subtract from the 100%, original one. When you're dealing with the percentage, an increase, you add, a decrease, subtract. So from our simple proportion, we can see that the 100 is it's a less value because 120 is bigger than 100. So this value is going to be less. So meaning to say our value is going to be the lesser value, which is 100 over the bigger value of 120 times 264 grams. So meaning to say the answer that you are going to have is in grams. We have removed the part of the percentage cancels. So that is going to give us grams. So like I said, this is you and your calculator. You're going to obtain 220 grams. Make sure that you use your calculator properly, depending on the calculator that you are having. Then item 2, you are given a painter got a 70% discount. That's a decrease after buying a large amount of paint. So we want to be careful there. If the discount was $91, find the value of the paint he bought. Okay. This question, if you're not clear, you are going to answer it wrongly because the 7% that we are seeing here, that is the discount. And they are saying if the discount was 91, if the discount, not the price after the discount, no. If the discount, what is the discount? We are given the discount percentage. And they are saying that discount percent as it is this time, as it is. Not to say you are going to subtract anything, but the percentage is the one that you are given. It's equivalent. The discount, if the discount was $91. Not the price after. If it is the price after, you were going to subtract this from 100%. You subtract the 7%. You get the 93%. This is the percentage that is going to be used to the price after the discount. But they never gave us the price after. They gave us the price of the discount. What was removed was $91. What was removed, that is what they are saying. We removed 7%. As a percentage, it's 7. But in terms of the money, it's $91. So that is exactly what they're trying to say. We are not given the price after, so do not subtract. You're taking the discount to the 91. So find the value of paint, the value of the paint you bought. That is, find the value of paint you bought. If they're saying this is the discount, so what was the amount of the paint? That is what they're saying. That is the amount at 100%. What was it at 100%? So this is going to be 100 because it's going to be more over 7 times 91. So that is, we can obtain the price of the paint, and that was going to be 1,300. So this is the original price of the paint. So that if you determine 7% of this 1,300, you are going to obtain exactly the $91, which is corresponding to the percentage. To say 7%, the discount is 91. So they can try to confuse you with these typical questions of this nature. All right, so that was what we had. Then B, AB is the diameter of a circle center O. So this is a situation where you can consider just to have a sketch. So AB is the diameter of a circle center O. All right, so just consider this is a sketch. So it's the diameter of a circle, meaning to say we have got the circle centered at O. Then they're saying AB is the diameter, okay? And C is the point on the circumference. So C is a point on the circumference. So C can be any point as long it is on the circumference. So there is a point C on the circumference of a circle, such that AC is equal to 7,5, BC 5 centimeters, such that if you join from A to C, you are going to obtain 7,5 centimeters. If you join from B to C, you are going to obtain 5 centimeters. That is the condition that you're given there. So you can just have a sketch. So this is 7,5 centimeters, and this is 5 centimeters. This is the situation that you're given, or the condition that you're given. Then you're asked to calculate the length of AB. AB is the diameter of the circle. This is our AB, which is representing the diameter. So how are we going to calculate this? We do not even know anything about this triangle formed as we joined from A to C and also joining from B to C. We formed a triangle, but what type of a triangle is it? You do not assume that this is going to be a non-right angle triangle. This is a non-right angle triangle. No. From our theorems, this is a circle because this is a part of a circle, so you can also consider the theorems of a circle. A diameter subtends an angle of 90 degrees. This is a diameter AB. Whether this point C was this side, we know that a diameter, what it does, it creates an angle of 90 degrees at the circumference of the circle. C is the point on the circumference, so meaning to say angle C is 90 degrees. So thus ABC is a right angle triangle. So if ABC is a right angle triangle, it follows that AB, the side to be calculated, is the hypotenuse, the one that faces the 90 degrees, that is the hypotenuse. And you are given two shorter sides. So thus we can use Pythagoras theorem. A squared plus B squared is equal to C squared, which is the hypotenuse, where A and B are the shorter sides. So you can just write the shorter side, 7,5 squared plus 5 squared is equal to C squared, which is the hypotenuse in this case, that is AB squared. You want to calculate AB, so how do you find AB? You can simply introduce the square root. So guys, all those simplification of this plus this is not even necessary. This is your working. You introduce your formula, you study it like that, it's fine. So you're going to obtain something like 9,01387, something like that. So to 3SF, that was going to be 9,01 centimeters. So these are centimeters. So your answer is supposed to be also in centimeters. So you see, when we talk about Pythagoras theorem, you expect to have a question that they are going to draw a nice triangle for you. They indicate this is A. They indicate the point. This is A, this is B, this is C. They indicate a 90 degrees for you. This is 5 centimeters. This is 7,5 centimeters. Calculate AB. No, these are questions from your textbook. This one. That is your textbook. That is why I say it is important that you do understand how questions are being asked. Your textbook, it gives you the knowledge of the topic. But question papers now, they bring everything that you have studied into one question. You are studying, you're talking about psychogeometry, you're talking about the solving triangle, the trigonometry at the same time. That you never find in your textbook, because your textbook focuses on psychogeometry on its own, solving triangles on its own. So revising question, it helps you now to observe something like this. So this is what you are supposed to actually, our question was supposed to be like this. This is what you're supposed to be given, your question as. They were supposed to give you a triangle like this. Find AB. No one was going to fail this question. You are used to this, but now look how they ask. The same question that you are used to. So revise, do yourself a favor to revise as much questions as you can. Revise as much questions as you can. All right, so this is another part of our question number 2, construction, which is something unfamiliar for us to see or to have question number 2 with construction. We are used to have this, maybe question number 4, question number 5 there, question number 6, but it was like this in this exam. So let's see. Answer the whole of this question on a sheet of plain paper. Use ruler and compasses only for all constructions and show clearly all the construction lines and arcs. On a single diagram, construct on a single diagram. Everything is supposed to be on a single diagram. So a lot of people saying, are they going to see all the arcs that I have presented? Do not worry for them. That is their job, to make sure they see that part. Everything must be done on a single diagram. That is why they're even emphasizing that. They know they are going to see everything that you're going to do. So make sure that. And they're even telling you that show clearly all the construction lines and all, not some, but all the construction lines and arcs. And after this instruction, you still feel pity for them to say, are they going to see if I make many arcs? No, that is what they're saying. Show clearly all. Do not limit yourself when answering these questions, because the more you limit yourself, the more you are taking away the marks. Every working, let it be on that paper that you are writing. Everything, let it be on that paper. That is the part of working. You take away the working, you throw it away, you present only answers to ZIMSEC. What have you done? So make sure you present all workings where there is a need of workings. All right, so this is triangle ABC that we are given with AB 6 centimeters, AC 5,8 centimeters, and also angle BAC being 135 degrees. I said everything must be taken from a sketch. And from this sketch, there's an angle. So just make sure the angle is on the base. So as you can see, this is an angle of 135 degrees. And you have a sketch like this. I'm not saying it's wrong, but also just try to show that you understand also your angles. An angle that is an obtuse angle is an angle that is wide open like this. That is what we understand from our angles. That's an obtuse angle. This is a presentation of an acute angle, this angle here, and this being the reflex. So at least to show that understanding, I'm not saying it's wrong because the sketch, that one, is just a sketch, but just try to be clear about your sketch. All right, so if I am to present my 135, I can just have something like this to indicate, or maybe I was gonna have it this way. It does not affect anything. You can have your triangle this way. You can have your triangle this way. That part does not affect anything. So if I am to say this is 135 degrees, it must be at least on the best. Try to have your angles on the best than to say you present your triangle this way, then you present 135 on top. No. Just try to have your angles on the best. So the angle that we are given is at point, that is at point A, all right? That is BAC, BAC. So considering to say it's BAC, we can just call it BAC so that we've got ABC, all right? Triangle ABC, angle BAC, okay? So that is how you can present this. Then we are given that AB is 6 centimeters. So this is just a sketch. And also AC was 5.8 centimeters. So on the sketch, it is enough this part that you are having, then you can now construct exactly the triangle that you're given. So the sketch is just to present like what are you going to have at the end. You are constructing something that you already know, like I'm going to have something like this. That is the idea of the sketch. All right. So let us have our constructions. Yes. So like I said, you're gonna have this part here. Okay, let me just try reduce a little bit. All right. So I'm just gonna use this. Okay. So the first thing on this part is to construct just a line of your choice. You can just construct a line of your choice. Then on this line, you mark a point that you're going to use as a reference point. Since there's an angle of 135, which is according to our triangle, it's on the left side. So it's best that our point must be at least to the far left. The point that you are using as a reference point, just at least try to have it to the far left like this. Okay, so how am I going to have 135 degrees? We do understand from our construction, we only have a 90 degrees and an angle of 60 degrees. These are the only angles that you can construct direct. But out of these angles, we can construct other angles. 135 degrees, as you bisect the angle of 90 degrees, you are going to have 45 degrees, 45 degrees. So if we add the 90 degrees to the 45 degrees, it means this whole angle that you're going to have is going to be 135 degrees. So in order for you to have a 135, you must think of a 90-degree angle. So we are going to construct a 90-degree angle. Then we bisect the angle of 90 degrees. Remember how you construct your 90-degree angle. This is your basics. You mark the point here, another point on the other side. Then you move to these 2 points, open more than half. Then we are going to construct an arc on top and another arc from this side. If you want, you can construct another arc down, but there's no need because already there's a reference point. So what you just need is to construct another arc from the other end without changing the length that you used to construct the first arc. So with this, you are going to join to the reference point, that is joining to the reference point, this is the 90 degrees. So some, they even do not join the 90 degrees, they just bisect it direct. That is, if you understand these constructions, guys, you can take your construction to that level, which is fine. So in this case, we're going to have something of this nature. All right, so this, just draw, construct a broken line like this. There is a broken line indicating this is 90 degrees. Don't even indicate that this is 90 degrees. Do not worry, guys. They are going to see that. Do not even worry for that. For these guys, they are going to measure everything. Don't even indicate. You want to obtain the 135, but which side? Is it supposed to be like this, that this is 135? No. The 135 that we need is inside of the triangle. So it's supposed to be like this. So if we bisect this side, it means the 135 will be inside. So do not make a wrong part of construction where you bisect this side. Bisecting this side, you have left the 135 outside. This is the 135. And what you are working with is the 45 degree. You are now working with the 45 degrees, which is wrong. Avoid such mistakes. We need the 135 to be inside of the triangle, so we bisect this side. Remember to bisect an angle, mark at this point, then you're going to mark 2 points along the line, so at least we need something, all right, that we can also, okay, this side, I think it can work. Just make sure the part that you use is also along the line. So you mark an arc this side. You do the same thing on this side of the arc of the line. You mark an arc like this. So on these two arcs, which is this point of intersection with the line, and also this point with intersection of the line, these arcs that we just constructed, without changing this distance that you have, okay, you're going to place your compass on this point, mark an arc this side, okay, where you want to have the 45 degrees, and also this side again, you mark these 2 points. So this part, or the intersection of these 2 arcs, as we can see, these 2 arcs, they are intersecting. Where they are intersecting, that is our 45 degrees. We have presented an angle of what? Of 45 degrees from there. So this is how you can construct any angle that you have, any angle of your choice. All right. I mean, any angle of this, from this angle of 45 degrees from any side. This is what I'm trying to say. Like the choice, like to say, which side are you going to consider? We can construct that. All right. So in this case, I'm just going to join these 2 points. Okay. Sorry for that. So if I join these 2 points, this must be at 135 degrees. So construction, you must have like the idea of the angles in mind also. You have the idea to, you are combining this in mind, a 90 degree and a 40, because this is a 45, this is a 45. So if you add 90 plus 45, that is to combine. If you add 90 plus 4, what are you going to obtain? 135. So this is at point A. From point A to B, that is 6 centimeters. So in that case, you are going to measure 6 centimeters on your ruler. All right. As I said before, on these measurements, you measure the 6 centimeters on your ruler. So you can even place your compass on your ruler like this. All right. The needle point on 0 there. Then you stretch 6 centimeters at this point. Something like this. So the 6 centimeters that you're having is the one that you're going to measure, that you're going to mark on this point of your, on this part of your line. So you mark the side that is 6 centimeters. Okay. That means you are at point B. So this is your point B. Again, from B to C, we do not know about this so far. We must have the point C. So where are we going to have the point C? From AC, because A is neutralizing everything, like the central point. From A to B, which is 6 centimeters, and also from A to C, which is 5,8. So you're going to measure 5,8 like this. With the 5,8 centimeters, you mark this on line, on this line, that is to mark the point C. Okay? So you've got the point C taken from A, 5,8 centimeters from A. So that is the idea of your construction. And this is you and your ruler. You join these 2 points, C and B, to complete the triangle that you have formulated. That is the whole idea of your triangle. If you're given a triangle like this, so let us just hope we have typical questions of this nature, which might be direct, not that direct, but at least a triangle like this one, it was easier to construct or to have. So by joining, this is what you're going to have at the end. Okay, that is, we have joined B and C, but you're using your ruler. In this case, you're going to use the ruler. Okay, so this is what we had. You can just reduce the lines. Do not erase any construction, any arc, like to remove these arcs after constructing. These arcs are required. They need this. They need to see these arcs. So that's your construction. So on this construction, now you are being asked item 2, the perpendicular from C to BA produced from C, from point C to BA produced. I talked about this when they're saying to BA produced or AB produced, they mean you can extend that line. As long it's along the line AB, you can even extend. They are saying AB produced, we can extend this line AB, all right? So something like this, you can even extend this line like this. That is a BA produced. You can extend if you've got a shorter piece that side, you can even extend this side. So the question is, construct the perpendicular from a point C, from a point to the line AB produced, this one. We must have a perpendicular. It must be at 90 degrees from point C. That is a perpendicular. So how do you construct the perpendicular from a point? I talked about this from other constructions that we had before. You can consider by using other questions so that you do understand much. I said you just need to construct an arc from the point C along the line AB, which is the line BC produced. So you're just going to mark at point C, then open a distance. That is, the arc is supposed to at least cross at 2 points along this AB produced. Not on this part of AB. As long it is along this line, do not worry. Don't focus to have your points on these 2 points here, A and B. No. As long it's along the point, the line AC. Okay, so it must be from the point C. So the needle point at C, we can construct an arc like this. All right. So I want you to see. All right. So let's see here. Let me just start off here like this. This is the arc. So this arc is giving us 2 points. It is at 2 points on the line BA produced at this point and also this point. These are the 2 points, this point and this point. So on those 2 points, you're going to mark again the arcs back to the point C All right. So marking the point C is just an indication to see if we are truly having exact construction, but otherwise you're not even supposed to mark at point C. You're supposed to have an arc on the other side down here. All right. You do the same thing at this point, which is the intersection of the arc and the line AB. All right. So we are going to have an arc. As you can see, these two, they intersect, and also it must intersect with the C, which is the original point that we had before. So this point of intersection, remember from C, if you join, this must be at 90 degrees. So that was the idea. So using your ruler, you join from the intersection of this point C to the point of intersection on the other hand, like that. So that was going to give you the perpendicular from point C to BA produced. This one, it is at 90 degrees. It is at 90 degrees. As it meets this line, it is going to meet this line at 90 degrees. Okay. A parallel line to AB passing through C. A parallel line to AB. We must have a line parallel to AB. From the locus, we understand that a parallel line, it is drawn from the locus of points equidistant from a line like 3 centimeters, 5 centimeters from AB. We know that we have a pair of parallel lines this side and this side. But this time they're saying we are supposed to have a parallel line, a line that is parallel to AB, and it must pass through the point C. So this line is supposed to be like this, passing through C, parallel to AB. That is, they will never meet. But how are we going to draw this line? From the concept of a parallel line, we know that parallel lines, they maintain same distance throughout. They maintain, for a line, for lines to be parallel, they have maintained the same distance throughout. That means they will never meet. If they are maintaining same distance, they will never meet. So which distance are we going to use as a reference? Because we are given AB produced to the point C. This is going to be our reference, this part. This is the distance that we are going to maintain. So we are going to simply measure that distance or take that distance. Just take your needle point here. All right, then across to the point C. All right, so take it to the point C. This measurement that we are given here, which is somehow 4,1 or 4 centimeters there. With this measurement that we are given from this point to C, it must be the same even if we take it from the point A. Even from the point A, we must have the same measurement that we are given there. It must be the same even from the point B. We must have the same measurement in between. This is to show that lines are parallel. So this can be an advantage because we can simply join these backs of the arcs that you are given. At the back of the arc, you join like this. As you can see, the line that you are going to produce there, it is parallel to AB. This line is parallel to AB. They will never meet. They will never meet. So that is the idea. So construction now brings, like you are doing this using construction, but this is the knowledge that you have about your shapes. But you are constructing that now, bringing it into the existence. That is the construct. So you must have your mind outside of construction, but under construction. but have your mind outside. The geometry part, properties of shapes, everything. That is the idea of construction. All right. Then another part, you were also given the locus of points, this time 4,5 centimeters from B. 4,5 centimeters from B. Remember, the locus of points from a point, it's a circle. So you measure 4,5 on your ruler, 4,5 centimeters. With the 4,5 centimeters, press it at B. So, I mean, you're going to have the need to point at B because it's from B. B, it's a fixed point. So this is 4,5 centimeters. We can draw a circle. So a circle is to be produced by this. This is 4,5 centimeters from B. All right. Then the other question now was the line parallel to AB passing through C, which is this line, the line parallel to AB passing through C, represents a certain locus. Describe this locus fully. As I was constructing this, I also talked about this locus to say, remember when you're to draw a parallel line, it was actually a locus. The locus of points, a certain distance that is taken from what? From the point, from the line AB. So the distance that we are given is the one that you're simply going to measure. Remember how you construct parallel lines. So if you were to measure the distance in between these parallel lines, if you take it from the perpendicular there, according to my ruler here, it's something like 4 centimeters, 3,9 or 4 centimeters. And is the same distance throughout of that 4 centimeters along the line from the point from the line AC. So this is the locus of points, a certain distance from AB. And that distance, as I measured mine, it was 4 centimeters. So I can consider that it is the locus of points. It is the locus of points. You take the measurement that you have obtained there. What you're obtaining is what you write. 4,1 centimeters, 4, this, whatever that you're obtaining. 4 centimeters from what? From AB. A line from A, not from a point. From a point, it's a circle. From a line, it is supposed to be a pair of parallel lines. If we just leave it like this, this one, it is a pair of parallel lines that you have described here. But this one is not a pair of parallel, it's just one line parallel to AB. So how do you best describe that it is just only one line parallel to AB? So eraser on the same side of AB, as you now specify where the parallel line is. Locus of points, 4 centimeters from AB. On the same side. So this is on the same side of AB as C. On the same side of AB as C. That is where our line parallel to is. So you must be careful when answering your question. It's just not just like locus of points equal to you. No. What exactly that you are given there? Is it the one that you're presenting? Is it the one that you're presenting there? All right, so that was our construction. Like I said, in most cases, you're supposed to have these constructions, question 4, question 5 later on, but that is what you had. Then question number 3, the universal set is subsets P and Q. So this is the universal set. Such that the universal set is having elements of x, such that x is an integer. Talking of the integers. Where the x, the one that you are referring as an integer, is to be greater than or equal to 30, less or equal to 40. Meaning to say 30 is included, 40 is also included. So the integers that we are going to list from 30 to 40, 30, 31, 32, and so on. 33, 34, 35, 36, 37, 38, 39, up to 40. These are the integers that you're going to have. P is the set of the values of x, so that x is a prime number from these numbers in the universal set. P is of the prime numbers. Prime numbers. So which prime numbers are you talking about? There is only 31 there. There is also a 37. These are the prime numbers. And the Q is a set representing what? The multiple of 4. If you divide that number, like let's just say you take a number, you divide by 4, you must obtain an exact value. So which of these numbers are the multiples of 4 that you can consider? There's a 32. If you divide by 4, obtain the exact value, which is 8. So that is, we've got 32. We also have the 36. It's a multiple of 4, and also the 40. So all these are multiples of 4. So the question was A, item 1, find the number. This is N for the number of elements in P. How many elements are we having in P? That is the question. So the number of elements in set P, you are to count the elements in P, 1, 2. So there are just 2 elements. How many? This is not to, this is to list 31, 37. You are listing the elements in P. But how many? That is the number of elements in P. Item 2, list the elements of Q intersection P complement, where P is the complement of set P, like the complement, like what we are not having in P. So if we are to consider this part of our P, as we can see, there are just 2 elements, P, 31 and 37. So the complement of P is to remove 31 and 37 from the universal set. This is the complement of P. What is not in P? These are the elements not in P. So the question is, we need the intersection of Q. This is our set Q. And the complement of P, which is what is not found in P, this part. Intersection. What is it that we are having in both sets? What are we having in both? So you see that we've got the 32, we've got the 32. The 36, the 36. So it was just a repetition of set Q. The 40 and the 40. This is what we just said. List, you must indicate the values. What is it that we have in that set? It's different from a question which is giving you the number, like to have the number of elements. The number of elements, you are stating how many elements are in that set. But list, you must list everything. So that is what we had there. All right. So let us consider another part of our question. We're just going to see what we are given. This is B, part of our question 3. So in this question we are given that is in triangle XYZ. Are we having the triangle? No. So it is best that you just have a sketch. This is just triangle XYZ. So you can just name X, Y, Z. Okay. So in this triangle, we are given that XZ is 17 centimeters. So XY, that is XY is 17 centimeters. Then XZ is 8 centimeters. Then YXZ is 65. There's an angle here. YXZ, this angle is 65 degrees, 30 minutes. So these are minutes. So we've got 65 degrees, 30 minutes. So the question is, calculate the area of triangle XYZ. Okay, seeing that this is a non-right angled triangle that we are given. It's a non-right angle triangle that we are given. So the area of a non-right angle triangle, how do you present the area of a non-right angle? The area of a non-right angle triangle is half AB, the sine of theta, or the sine of C, where A and B are the sides creating the angle that you are given, the included angle. So meaning to say our area is going to be half of A, just going to consider the two sides, 8 times 17 times the sine of 65 degrees, 30 minutes. So it's either you're going to convert the minutes to degrees, that one is up to you, all right? Or you can just use your calculator. Your calculator, it knows everything. That is why you are using calculators in this section. The calculator is there. So make sure that you present properly the degrees and minutes, the degrees and minutes on your calculator. So this is what you were supposed to have, something like this. Okay, so you're gonna have here, this is the degree, minutes and seconds, this button that I'm pressing here. So this is how you're gonna present, that is half of 8 times 17, and then times the sine of 65 degrees. So this is 65. You press this button, that is, it is indicating the degrees. The moment you press it once, that is degrees. 30 minutes, you press this again, that is minutes. So that is how you can have your calculator direct. So that was going to be 61,877. So to 3 significant figures, that will be 1, 2, 3. 7 changes this into a 9, that's 61,9 square centimeters. So that is how we're supposed to have this. So these are questions that you are used to where they draw diagrams for you. But now it's a given condition that you need at least to see what is it like on a sketch. See, there are 25 red sweets, X blue sweets in a box. One sweet is selected at random, only one. Given that the probability that it is blue is 3/8, find X. Remember, X represents blue. The probability of finding blue in the original sense, it was supposed to be the number of the blue sweets, which is X. We do not know that. Over the total, knowing that we have got the 25, which are red, and X, which are blue, the total is the sum. This was supposed to be the expression for the probability of picking a blue sweet. But they are saying the same probability of picking a blue sweet numerically as a value, it is 3/8. This is the number, the presentation. So what is X, guys? This is one and the same thing. The expression for the probability and the numerical value of the probability are the same. So x over 25 plus x must be equal to 3 over 8. That's an equation that you're simply going to solve. To solve for x, cross multiply. So are you seeing how they are testing new equations at the same time? Probability. So cross multiply, that's 8x is equal to 3, multiplies everything in this part of the bracket. So 3 was going to multiply 25, which is going to be 75. Then 3 times x, which is 3x, collecting the terms of x to one side of the equation. That is going to subtract 8x minus 3x is equal to 75. It was a positive, so it's going to be a negative. So subtracting, that's 5x is equal to 75 divided by 5. So our x was going to be a 15. That is the idea there. Meaning to say, the blue sweets that we had, there were 15. Just like that. So this is how some of the questions, they might be just direct, guys. These questions, some of these, they are now as direct. And as you can see, it's not that much. You just need to work more questions. P varies directly as Q and inversely as the square of R. So P varies directly as Q. And that is another, that's a joint variation. There are two variations. Inversely, you know, it's over something. Inversely as what? As the square, not the square root, but the square. The square means to the exponent of 2. So this is our variation. Then we are given P and Q. This statement that we are given P is this, Q is this, and R is this part on its own, this part. It is going to help us to determine or to find the value of K. Remember, you introduce the constant. So P is equal to the constant times Q over R squared. Then substituting what you're given, P is 15. You need to substitute all this part that you're given. P is 15 when Q is 9. So this is 9 times K over R squared, which is 6 squared. So you can also simplify this on your calculator, guys. Some of these things, simplify. Your calculator knows everything there. 6 squared is 36. So it's just like 9 over 36, which is 1 over 4. So what we are seeing here is just like 1 over 4. Then you can cross multiply. The 4 multiplies this side to this 15. So that's 1 times K, which is K. 15 times 4, which is going to be a 60. Working with a variation, you know that you need a constant. They never asked you this. But you know that you are going to need the constant. With the constant, that is where now you start thinking of answering what is the question. So the problem is you want to answer the question, but the idea of answering the question, are you having it? Whenever working with a variation, you need the constant. So with the constant, we can conclude that P can be related to 60 Q over R squared. This is now the relationship that connects P, Q, and R. These are connected by this relationship, where we can find P by just substituting what we are given. What are we given? Q as 7. And what is the value of R? R is given as 2, so that's 2 squared. So meaning to say, this is your calculator. Just simplify everything on your calculator. It is enough. You're going to obtain 105. So that's the idea of the question. All right, question number 4, you're asked to remove brackets and simplify. Remove brackets and simplify. All right, item 1, you're given 4 into the bracket. So that is 4 into 3 minus 2p minus 3 into the bracket of 1 minus p. So they were simply going to distribute by 4. the first bracket, you multiply everything by 4. Then to the second bracket, you multiply by -3. There are two brackets that you're considering, but the first bracket is affected by a 4. So 4 multiplies everything. All right, that is 4 times 3, which is 12. 4 times -2, which is -8p. Okay, you do the same thing with -3. It multiplies 1 minus 3. -3 multiplies p. That will be a positive 3p. Collecting the like terms, that is the part of p, the numbers together. So we've got 12 and -3. So 12 minus 3, that is going to be a 9. Then you are left with -8 plus 3p. -8 plus 3p, that is -5. And that is -5p. Just like that. For 2 marks, guys. All right, expand the brackets again. On item 2, you're given 3q minus r into the bracket of q plus 2r. So there we are going to consider the same idea. This part multiplies everything, minus r also multiplies everything. So that's 3q multiplies q, which is going to be 3q squared. 3q multiplies r there, that is going to be 6qr. Okay, so you multiply this to here, you also multiply this to here. After that, you do the same thing, minus r times q, that is minus qr. Then minus r times a plus 2r, that is going to be a negative 2r squared. Minus and a plus. Okay, then you can also collect like terms. So you're going to have 3q squared. As we can see on this part, we have got like terms 6qr minus qr. So this is just same as there's a 1 there. So it's 6 minus 1, which is going to be a 5. So that's 5qr minus 2r squared. Just like that. You've expanded your brackets and collect like terms. Okay, then consider b factorize. There we just have to consider what is it that is common. 8 and 6 can factor out 2. That is the common factor. Then we've got a, b, and b squared. We're going to have b, which is the one with the smallest power. Then we divide 8 to 2. That is going to be 4. ab and ab was going to cancel. 6ab squared. This time, divided to 2ab, what are you going to have? That's a 3. A and A cancels. This and this was going to be B. So it was going to be 3B. So guys, and you say this is so much difficult. I don't see like where exactly are we missing the part there. All right. 18t squared minus 2. 2 is common between 18 and 2. So you can factor out 2, then divide. Remember the golden rule. Always you're supposed to factor out what is common. After that, you can consider the type of an expression that you're given. It's a difference of 2 squares. This is a perfect square. This is also a perfect square. So considering the difference of 2 squares, where you're supposed to find the square roots of these terms. The square root of 9, which is 3. Square root of t squared, which is 3, which is t. So it's going to be 3t. The square root of 1 is 1. Square root of 1 is 1. So one of the bracket is going to subtract and another bracket is going to add. Or one bracket adds, another one subtract. It's up to you. Which bracket are you going to start with? Addition or subtraction does not mean you are supposed to follow suit that that part. No. You are not supposed to follow suit plus or minus. No, you just whatever that you want, as long one is adding, another one is subtracting. All right. See item 1, we're given this, that y is equal to 18 plus 3x squared. From this part, find the value of y if x is minus 2. Guys, this is just a substitution in place of x. They are saying substitute minus 2 and use your calculator to simplify that. That's you, and the calculator is going to be a 30. Yes, you can write stage by stage. This is minus 2 squared. Means a minus 2 times minus 2. which is 4. Then it's going to be 18 plus 3 times 4, which is 12. Then we add, that was going to be 30. Just like that. Substitution. You are substituting in place of x. Find the values, not just a value, but they are values of x when y is 93. So again, it is a substitution. In place of y, we are going to substitute 93 is equal to 18 plus 3x squared. So let's solve and see for the values of x. You're going to transpose the 18 to this side. 93 minus 18 is equal to 3x squared. Whatever that you're going to obtain, you can divide. Okay, 93 minus 18, this was 75, is equal to 3x squared. You can even divide by 3 by 3. So x squared is equal to what? 3 into 75, that is 25. So how do you find the values of x given a square? You introduce the square root. So x is going to be plus or minus 5. That means x is equal to 5 or x is equal to minus 5. So these are values of x. The values of x. Two possible values as we saw. Express x in terms of y from the same expression. This is now change of subject. From the same question, express x in terms of y. So how can we make x the subject? Okay, gonna transpose the 18 there, subtract. It is equal to 3x squared. What is affecting x squared is 3. So you can divide by 3 by 3. That means x squared is equal to y minus 18 over 3. There is a square. So just like what we saw in the previous case, to remove the square, we must have the square root. So that's the idea there. So meaning to say x was going to be plus or minus the square root of everything. The square root of everything. The square root is supposed to cover up the 3, also is supposed to be under this square root. So this is y minus 18 all over 3. So if this formula is true, it means we could have used, if this is true, we can also prove that x is equal to plus or minus y minus 18 over 3. You can also find exactly the values of x that you obtained when y is 93. We can just substitute in place of y, there's going to be plus or minus the square root of, in place of y, that's 93 minus 18 over 3. You are still going to obtain those values that you obtained plus or minus 5. This is to show you that this formula is true for all values of x. For all values of x, it is true. All right, as a single fraction in its simplest form. All right, there we are given expressed as a single fraction. All right, so let's just see what you were given. So that is our question 5a. So you're given 4 over y minus 3 over y plus 4. We've talked about different methods, finding of the LCM, y minus 3, y plus 4. Then you divide this into this, whatever that you multiply. Okay, which was fine. But let us consider to say, if I do know that the denominators are the same, I can simply combine the numerators. We know that. So I can simply try to make this to have the same denominator of y plus 4, because I do not have the y plus 4. So I can simply multiply by y plus 4 over y plus 4. This is the same as multiplying by 1, so it does not affect anything. The same thing here, I need y minus 3 because I have y minus 3, but I do not have it here. So to have y minus 3, I'm going to multiply by it. Multiply by y minus 3 over y minus 3 simply means I'm multiplying by 1. It does not affect anything by multiplying by 1. What I simply need is this condition of having the same denominator, knowing that if the denominators are the same as this, you are subtracting or you are adding and the denominators are the same. What is it that you do? You simply combine the numerators as they are. You do not consider, say, I'm going to divide this. You just combine 4 into the bracket of y plus 4 minus 3 into the bracket of y minus 3. Combine the numerators under the same denominator, which is the same denominator. That is the reason of having the same denominators like that. Yes, we are going to have the same thing from that division. Guys, just learn some other ways of having this, okay? Multiply by 4, that is 4 times y, which is 4y times 4, that is 16. Minus 3 times y, which is minus 3y minus 3 times minus 3, that's a positive 9. Everything over y plus 4 into y minus 3. So this is what you're going to have. Then consider the like terms. 4y minus 3y, that is going to be 1y like this, which is same as y. 16 plus 9, that is going to be 25. Everything over y plus 4 into the bracket of y minus 3, just like that. Just like that. There is nothing that we can do from the numerator. This cannot be factorized. It is not the same as what we have in any of the brackets in the denominator. So there is nothing that we're going to do on that part. That is, we are done. So guys, you tell me that it is, after all these revisions that we are doing, it is actually difficult to obtain a straight A. From these revisions, guys, we must be able to obtain straight A's because this is something that is clear now from all that we have been having, that we have been doing previously. Anyways, let's see. B, solve the equation. They were just going to cross multiply. They are the same brackets, y minus 1, y minus 1. They just want to test you there. Do you know that 2 times 2 is equal to 2 squared? X times x is equal to x squared. If you know this, then why is it difficult to realize that y minus 1 times y minus 1 is also the same as y minus 1 squared? If x times x is x squared, therefore, if these two brackets are the same and we are multiplying same brackets, we're supposed to have a squared. All right. 8 times 2, that is a 16. So how can we remove the square, introduce the square root both sides, knowing that the square root is equivalent to a plus or minus? So that will be plus or minus a 4, square root of 16. So there are two possible values. So taking minus 1 to the right-hand side of the equation, that will be a positive 1. So meaning to say y is equal to 1 plus or minus 4 that we already have. Separating the plus or minus, meaning to say we're going to have 1 plus a 4, or we are going to have our y being equal to 1 minus a 4. There are two possible values there. So y was going to be a 5, or y was going to be a minus 3. So these are the two possible values of y that you're supposed to obtain from this equation. So you can even expand those brackets, go back to the factorization method, quadratic formula. Guys, it's up to you. As long as you do understand what you're doing, then it's fine. Solve the inequality. So this is a simultaneous inequality or a compound inequality where you are given two inequalities at the same time. So how do we solve such type of inequalities? We said in this condition, what you simply need is to separate the middle part of the inequality that you're given, which is the 4n minus 3. This is the middle part of our inequality. separated to the 21, that means 21 is less than 4n minus 3. The same 4n minus 3 can be taken as 4n minus 3 compared to 27 less than or equal to 27. So thus we've got two inequalities. This is what you are used to. These are inequalities that you are used to. So you can solve. Transpose the minus 3 to the other side, it becomes a positive, that is 21 plus 3. 24 is less than 4n, divide by 4. By 4, nothing is affected here. So 4 into 24, that's a 6. Okay, on the other hand, you can transpose the negative 3, that will be a positive. So that's 4n is less than or equal to 27 plus 3, that's a 30. Divide by 4 by 4. This is paper 2, guys. You can use your calculator. 30 divided by 4, that was going to give you 7,5. There are two solutions. The n which is greater than 6 and the n which is less than or equal to. Always, I said, the presentation, if it is in terms of x, must be always facing the same direction. The inequalities like this. Always. Where a is less than b, a is a value that is less than b. So in this case, it means therefore our n is what? The value that is comparing the 6 and the 7,5. 6 is less than, so n is greater than the smaller value, which is 6. But the same n compared to 7,5, it is what? It is less than or equal to 7,5. That is a single inequality. So I hope as you are revising other question papers, we have gone through this. Just make sure you revise. All the question papers are there for you to revise. They're there for you for that. So make sure you do revise as much as you can. All right. Considering the D, we are given the points P, Q, and R. I've got coordinates, this respectively. So this is P, this is Q, and this is R. Find the gradient of QP. Remember, the gradient of a line M is the change in Y over the change in X, Y2 minus Y1 over X2 minus X1. So gradient can be written by the letter M, or you can write gradient is equal to, if you want. That's your point P, 9,8, Q, which is 12,4. So that's just going to name X1, Y1, X2, Y2. So let's substitute Y2, that's a 4, minus Y1, which is 8, over X2, which is 12, minus X1, which is 9. In paper 2, this is enough for you to write the answer. This is paper 2, guys. Minus 4 over 3. So that's the gradient of the line PQ or QP. Then B, or then item 2, the equation of line passing through R. So the line is supposed to pass through R, which is given as 4 minus 2. That's we are given the point. And parallel to PQ, parallel to QP, what is it that we must consider if two lines are parallel? They have the same gradient. So it means the gradient of this line that we need to find its equation is also minus 4 over 3. They have got the same gradient. Letter M represents gradient. So remember, to find the equation of a line, if you want to use the format of y is equal to mx plus c, you can substitute m being the gradient minus 4 over 3x plus c. So c is the value of the y-intercept, that is the value to be found from the point where it passes through the point R. So you've got the x value and the y value there. So substituting the y value, minus 2 is equal to minus 4 over 3x, and x is what? Is 4, plus the constant, which is said to be found, which is the y-intercept. So minus 2 is equal to multiply this is ms over 1. So that will give us negative 16 over 3 plus c. If you were to transpose this to the other side, it was going to be a positive. Minus 2 plus 16 over 3 is equal to c. So that's the value of c at the end. That is the y-intercept, and that was going to be 10 over 3 from your calculator, guys. Paper 2, use your calculator. So you're just going to substitute, therefore, from this, because you have the c, so therefore y is equal to minus 4 over 3x plus c, which is 10 over 3. Just like that. The equation of the line. You need the point and also the gradient. So revise your basics, guys. Revise your basics of the topics, that of each and every topic. So this is section B. We are going to consider and see what we are given on our section B. So remember, your section B is you are to consider, answer carefully the questions that you're going to choose. Answer carefully. You are asked to answer any 4 questions from this section. Each question carries 12 marks. So answer properly, choose properly. So the first question, this was statistics, where we are given the information, the ages of 40 learners were recorded. All right, so these are 40 learners were recorded. The results are shown in the table below. That's the age, the frequency density. So already everything is calculated, is different from those questions that you have to calculate. Everything is calculated. State the model class. So the model class is the class with the highest frequency. Which is the highest frequency on these numbers? That is a 10. So the class with the highest frequency, that is 12, less or equal to x less than 40. That is the class with the highest frequency. That is the model class. B, draw a histogram on a sheet of graph paper using a scale of 2 centimeters to 2 units on both axes. So this paper, you were not answering on this paper, you were answering on a separate part. Guys, this is ZIMSEC. This is ZIMSEC. You must be just careful as you're answering your questions. All right, so let us consider a histogram. Already you're given our table. So remember that histogram you draw using the classes, which is the age versus the frequency density. Remember, you use the classes versus the frequency density. So using a scale of 2 centimeters to represent 2 units on both axes, we are going to have, this is our age. So it was XY here's, that is 0, 2, 4, 6, 8, 10, 12, and so on and so on. But if you consider this, you're not going to win, guys, because there, if we are to consider the first class starts at 8, ends up at 19, which is approximately 20 there. So it is actually something that is gonna be difficult. So you can even start at 8. All right, so you can even start at 8. That is gonna be 8. You maintain the scale difference of 2. So 8, 10, 12, 14, 16, 18, 20. We have got 19 in 20. So on the Y, we are going to start with a 0 there. So that is the 0, then that is our frequency density in this part. We're going to use the frequency density. So we're going to have 0, 2, 4, and so on and so on. As we saw that the bigger value that we had there was 8. So at least up to 8. All right, 6, 8. All right, I think we can accommodate 8 if we list up to 10. So this is just like a normal part, guys, from 8 to 10 with a frequency density of 3,5. You just need to understand your scale, whatever that you are given. So that is the frequency density is 3,5. 3,5 is going to be, okay, let's start with the 3 first. In between 2 and 4, that is 1, 2, 3, 4, 5. So in between, that is our 3. So 3,5 is in between 3 and what? 3 and 4. In between. So that is 2.5 boxes. 1, 2.5 in between. So you're going to count 2.5 boxes from this point. That is, you're going to count 2.5, 1, 2.5, somewhere there. All right. Then you join from 8 to 10. That is the idea of this part. So we're going to have just something like this in between that 2,5. Then this one joined to 10. All right, so just somewhere there, not exactly but just approximately at the in between. So because this is too bold, so you're supposed to use a very sharp pencil in your presentations. Okay, then let's check the other one from 8 to 10, then from 10 to 11 versus 8. All right, that is from 10 to 11 versus 8. The frequency density that we are given is 8. That is somewhere there, 8. But this is 10 to 11. So 11 is in between 10 and 12. That is, you count 5 boxes, 1, 2, 3, 4, 5. That's somewhere there. So that is, we're going to join from this point. Okay, sorry for that. That is straight from this point up to 8. Okay, let's just hope we guys, we are at that point exactly. You're supposed to do the exact thing, guys. Here is because, guys, this is software. This is not, I'm not using a ruler. It's a software. So at least you understand like what you're supposed to have from 10 to 11 versus 8. You have the same thing from another class, which is 11 to 12. So this is 11 to 12 versus 6. So this is 6 somewhere here. That is 11 to 12 versus 6. So you just do the same thing. Join to this point, and you're going to join these two. Okay, something like that. Okay, that is 11 to 12. From 12 to 14 versus 5. Okay, 12 to 14 versus 5. So that is 12 to 14 versus 5. So 5 is in between these 2 points, right? So the last one is not exact, but this is because these lines, they are too bold. But 5 from 4, you're just gonna count 5 boxes, 1, 2, 3, 4, 5 in between 4 and 6. All right, that is in between 4 and 6. Then you can join just like the previous case. All right, that is in between something of this nature. All right, so guys, just try to be at least clear in the presentation. 14 to 16 versus 1,5. 14 to 16 versus 1,5. So as it is, guys, as it is. So 1,5 again, you need in between 1 and 2. So you need 1 first. Okay, so that is 1 is in between 1 and 2. That is 1, 2, 3, 4, 5. This is where we have 1. So you're gonna count 2 boxes, 2.5 boxes. That is 1, 2.5. That is where we're gonna have 1,5 because 1 is here. Then 1,5 it's in between 1 and what? It's in between 1 and 1,5. So that is the idea of the question that you're given there. All right, so let's see somewhere this one to just gonna join. Remember, it's 14 to 16. That's gonna be something like this, then in between. So just make sure you are exactly along the 4 comma, along the 1,5. I mean, just along that part. Then the next class that you were given, if you're to consider, that was the 16 to 19 versus 2. Okay, 16 to 19, 16 to 19 versus 2. So 2, that is here, but 19 we're gonna need in between 18 and 20 there. That's 1, 2, 3, 4, 5, somewhere there. Okay, but it must be versus a 2. It must be taken at 2. So this is you guys and your a ruler. Make sure you have got your constructions, I mean your lines properly joined, something like that. So you are going to obtain the histogram of this nature. You use a ruler when you are joining this part. Yes, because if I try to have the ruler part, is going to take us a lot of time, but you're supposed to use the ruler in these constructions. You're supposed to have a ruler. So this is the part of the graph. So it was a separate part on its own. It was just a separate part done. Let's move on to another part. So this question, we are not even asked to use the graph. It's a question on its own. Calculate an estimate of the mean. It has nothing to do with the graph. You are back to the table. How do you calculate the mean? Remember the mean from the class centers. I talked about this, that you need the class centers. All right. So from the class centers times the frequency, each and every class center multiplied to the frequency. Each and every class center multiplied to the frequency. So the class center of the first class between 8 and 10. How do you find the class center? The lower class plus the upper class divide by 2. So that was going to give us a 9. So meaning to say we need the class center here, which is a 9. The class center between 10. So even by sight, by just looking into these numbers, guys, the number between 8 and 10, that is the class center between, just like a mid value, a midpoint between 8 and 9 is between 8 and 10. Is there a number between? That is the number there is 9. So that is the class center. So you take the class center to the frequency. All right. So that means our mean was going to be 9 times the frequency of the first class is 7. Plus, you do the same thing. The class center between 10 and 11, the number between 10 and 11, 10,5. You can add 10 plus 11, you divide by 2, but that's 10,5. The frequency, 8. So this is, and so on and so on. Between 11 and 12, that's 11,5. The frequency being 6. So that's 11,5 times 6. Frequency being 6. All right. Between 10 and between 12 and 14, the number between, that is 13, times the frequency, which is 10, plus between 14 and 16, the number between there is 15. So that is 15 times 3, plus between 16 and 19, if you add 16 plus 19 divided by 2, you are going to obtain 17,5 times the frequency, which is 6. Class center, frequency, class center to the frequency, class center to the frequency. Everything that we are having here over the total frequency. We were supposed to add these frequencies, 7 plus this, but we are given the ages of what? 40 learners. We are already given the total. There are 40 learners that we are working with. So that was going to be the mean. All right, so this is you and your calculator here. Simplify everything on your calculator. You are going to obtain 496 over 40. Just also confirm on your calculator, that's 12,4. That is a direct value that you're having there. That's the mean of the given information. Okay? The D part you're given, one learner is chosen at random from this group. One. It's only one. Calculate the probability that the learner is below the age of 8 years. Below 8 years. The age that we are given of these 40 learners are in this group of 40 learners. The minimum age that we are given is 8. X is greater than or equal to. We do not have anything that is less than 8. So the probability of something that does not exist is a 0. That's 0 out of 4 does not exist. We do not have any age below 8. All right. Item 2, below the age of 16 years. Below 16 years, we are going to consider X must be less than 16, below 16. So below the age of 16, this is everything up to 8. It is below 16. Everything. 11 is also below 16. So we are considering everything below 6. We are going to add everything. 7 plus 8 plus 6 plus 10 plus 3. So instead of us adding all these numbers, just tick what is remaining is 6. So remove the 6 out of 40. 40 minus 6 is what? That is 34. So meaning to say the probability there, they are 34. If you were to add those learners, they're going to be 34 out of 40. And that's 34 out of 40, which is going to give us 17 over 20 in simplest form. If you use your calculator, it's going to give you 17 over 20 like that. Then E, we are given if this time two learners, we are talking about two learners, are chosen at random, find the probability that they are both in the age group of 14 to 16. Both. There are two learners, they are taken from the same age group of 14 to 16. We have that age group properly presented from 14 to 16. How many learners are we having? There are 3 according to the frequency, that is the number of learners that we are having there. So there are 3 learners out of 40. This is the probability of picking the first learner, but you pick again from the same group. You pick again. So meaning to say we are going to have 2. Remember there were 3, so we are remaining with the 2 learners out of 39. Even the total will be affected. So that means we're going to have 1 out of 260. You can also have it as a decimal. It's up to you. So that was the condition of our question 6. Statistics, as you can see, it was a little bit direct according to what we are seeing here. It was a little bit direct. Then question 7, the following table gives the values of y is equal to, so given that is y is equal to 6 minus x squared. Find the values of p and q. So as we can see, p is the value corresponding when x is minus 4. So you just have to substitute when x is minus 4. So p is equal to 6 minus, in place of x, you substitute minus 4, minus in place of x, you substitute minus 4, that is minus 4 squared. So p was going to give us a negative 6. This is the calculator. Use your calculator to simplify everything. So it's the same part with q. When x is equal to 0, just substitute a 0 there. As you can see, you're going to remain with a 6. So the value there was going to be a 6, which is the value of q. So that is what we're given from the first part. All right, let us just also just remove this. We're done with this one. Sorry for this. So these are the typical questions that you are given. And there we are given now from the table that you're given. This time they're saying this part that we are given here, the rest, there's an instruction, answer the whole of this part. The whole of this part of the question on a graph paper. Use a scale of 2 centimeters to represent 1 unit on the x-axis in the range from -4 to 3. These are the x values, x taken from -4 to 3, and x is 2 centimeters to represent 1 unit. So we are given the interval, the x values to be taken from, and given a scale of 2 centimeters to represent 1 unit. So you've got a 0 there, then you're gonna have 1, 2, 3, 4. Even if we just consider 5, then -1, -2, -3, -4. This will be fine. Actually, you can even just consider -5, but it's okay. -1. All right, so let's leave this one for y. For the y, we are given something else. According to the y, we are given and 2 centimeters to represent 2 units on the y-axis. This is on the y-axis in the range, in this range, -6 to 7, but it's 2 centimeters to represent 2 units. Each and every 2 centimeters represents 2 units. So you're going to have -2, -4, -6, -8, which is actually enough to cover -7 or -6. Then we're going to have 2, 4, 6, 8, and so on. So that is your Cartesian plan. It must make sure that your Cartesian plan has got all the possible values that you're given within the interval that you're given there. So marking the points that you're given, remember now you've got the points like from what we had, because they were supposed to draw this graph from the table that we had. So you mark the points -4 versus 6, -3 versus 0, and so on, up to the last one. We are marking these points on our graph. So starting with -4 versus -6. So using these points, we had -4 versus -6. That's -4 and -6 somewhere there. Then we're given -3 versus 0. That is -3 versus 0. -2 versus 4. It was -2 versus 4. It was -1 versus 6. It was 0 versus 6 again. Then it was 1 versus a 4. Then we're given 2 and a 0. 3 and a -6. So this is the part that you are given according to our table. So with these points, you are going to draw a smooth curve from these points that you're given. So just gonna try here to have a smooth curve. So guys, you are supposed to have a smooth curve. So according to me here, mine is just gonna be something like this. Then there you're gonna have a curve to the 0.6. All right, then drawing. So you got advantage because you can even rotate your book in the way that you want. So here, guys, I can't do that, but I just hope it's gonna be something that you see. All right, so like I said, something like this, but you're supposed to have a clear graph. This one of mine is not that clear. You're supposed to have a clear, smooth graph. So this is y is equal to 6 minus x squared. You write down the equation of the function that you're given and use the graph. Use the graph to find the maximum value of this, the maximum value. So now, because of the way that you have presented, because the maximum value, guys, is the value at the turning point here. you must draw with the ruler straight to the y-axis. That is where you obtain the maximum value somewhere there. So now, because you are using this graph and somehow you might not be having an exact like this curve, that you remember this curve, it might be different. So it differs now on our maximum values. So how can I obtain exact values? It follows that at the maximum or at the minimum value, if the graph is like this, you talk of the minimum value of the function. So it follows that at the maximum or at the minimum value, the value of x is the average. The value of x, which is the line or the axis of symmetry, is the average of the x values taken along the horizontal line. Any horizontal, if you take along the horizontal line, the average of the x values on the graph, there is a -3 there, there is a 2. The average, the value of x, if you take along this, you can see along this horizontal line, the x there is -2, the x there is a 1. The x there is corresponding to a 1. If you take along this horizontal line, the x there is -1, the x there is a 0. So the x being the average value, which you add x1 and x2 over 2. This is the x at the turning point. At any turning point. That is at any turning point. As long these x1 and x2 are taken along the horizontal line. So you just draw a horizontal line cutting or crossing the graph. So if you take this along this horizontal line, there is -3 and 2. So x is going to be -3 plus 2 over 2, meaning to say you are going to obtain -0.5 or -half. This is the x at the turning point. So if it is the x at the turning point, therefore I can substitute this now to obtain the maximum value of the function, because according to the maximum value, our x is -0.5. So substituting into that equation, remember it was 6 minus x squared. So you can substitute this one, you obtain the exact value. You are not going to miss this one. You obtain the exact value, even if your graph is not smooth. It gives you the answer that they are having on the marking guide. That is how exactly you're going to have. So it is going to give us the maximum value of 6.25. Okay, so that was supposed to be the maximum value. So it follows that at the maximum value, the value of x, you substitute, even if it was the minimum value, you substitute the x at the turning point. And to find x at the turning point, I said you just add x1 and x2 over 2 is the average. As long you take along the horizontal line, consider this horizontal line. What are the x values there? If you consider there, x is -2, and according to this one, x is 1. So you take the x values along that horizontal line, along this horizontal line. X is corresponding to -2. X here is corresponding to 1. So if I add these, -2 plus 1 over 2, I must obtain the same -half, which is -0.5. If you take this horizontal line, the x there is -1. The x here is a 0. You add -1 plus 0 over 2. You obtain the same answer throughout, as long you are taking along the horizontal line. That is how you can find the x at the turning point, or the x that is representing the equation of the axis of symmetry or the line of symmetry. At that point of x, if you substitute it, you obtain the maximum value or the minimum value, depending with the graph that you be given there. That is how you obtain exact values. All right, so that was our maximum value. Then item 2, the equation of the line of symmetry. This is exactly the one that I was talking about here. So already when you're calculating this x value, you're obtaining what? You're obtaining the equation of the line of symmetry. Remember, that is the x at the turning point. So already x there is minus 0.5. This is the line which divides or separates our graph into two equal parts. So if your graph is not smooth, use this concept. Just add the x value. You obtain exact answers rather than to use wrong answers where you have got an option of obtaining correct answers. Then the gradient, when x is equal to minus 2, when x is equal to minus 2, how do I determine the gradient? Remember the gradient of the curve, you are going to draw a suitable tangent at x is equal to minus 2. So again, this one, you can have exact answers if you consider the part of the derivatives. But the reason why I do not focus with that part is that because if you consider any other function which is not a quadratic or a cubic, maybe it's an inverse function, you guys will find it challenging now to have the same concept or to use the same concept. So I always stick to this part, trying by all means so that you understand. Remember, we are going to draw a suitable tangent. A tangent is the line which just touches the curve. It is not going to be inside of the curve. It just touches the curve at that point, at point minus 2. At point minus 2. So with this tangent that you are given, you are going to choose 2 points. Remember, in order for you to have the gradient, you need 2 points. Okay, so you're going to need 2 points. So the 2 points, one is supposed to be the reference point, which is at the point of minus 2, where x is minus 2, y is equal to 4. So that's the first point where you are calculating the gradient at x is equal to what? That is your first point. And the second point is any point that you take, as long you take that point along this line, along the line, not the curve, but along the line, this tangent, as long you take a point along that line, there are so many points. Minus 3 versus 2, minus 1, it was going to correspond somewhere there to a 7. So there's minus 1, 7. There is minus 3, 2. Any point that you take. So I'm going to take minus 1 and 7. So these are the 2 points that I'm going to take along the line. With these 2 points, if I calculate the gradient, I'm supposed to obtain the, that is how I determine the gradient. Remember, the gradient is the change in y over the change in x when given 2 points. So that means I've got my x1, y1 here, x2, y2. So that is y is 7 minus y1, which is 4 over x2 minus 1 minus x1, which is minus 2. So that was going to give us the gradient of the function, which is equal to 3. So I want you to take any point. So you're not going to have exactly the exact grade, but this is the exact answer, 3. According to this slope of mine, this is the exact slope. So it's giving us the exact answer. But according to you, you might have maybe 3,1, 2,9. Yes, they are going to mark those answers. Just try to make sure that your answers are within the interval that you are given. So that is the gradient. So if you follow up I want you to just check those N3 subjects for maths, N3 maths. You can even check the derivatives or differentiation. It is another way that you can use to calculate the gradient of a curve using the derivatives. It's a method, it's a topic on its own. So you can check derivatives for those who are like into these mathematics. You want to further up your mathematics with other topics or other areas, you can actually you can do that. You can do that. It is best that you do that so that you can even have an understanding about what is the gradient. The gradient, it is best explained with the derivatives, which is differentiation, which is another part that is you're going to have in your A-level mathematics there. Item 4, the area bounded by the graph. It is between the graph, the x-axis, the y-axis, and the line x is equal to -2. Bounded by the graph, the x-axis, meaning to say we are somewhere there. The y-axis, meaning to say there are two regions. The moment we include the y-axis, the region in between the graph and the x-axis and the y-axis, it is either this side or this side. When they say and the line x is equal to -2 and the line of x is equal to -2, it is now differentiating the region that we are going to take. In between, it must be bounded. Which region is bounded by the graph, the x-axis, the y-axis, and the line x is equal to -2? This is the region bounded here, in between. That is the area guided, bounded, covered by all the given lines and curves. So how do you calculate the area? Remember the formula for area. You can use the concept of calculating the number of boxes. Calculating the number of boxes, where area is going to be the number of boxes over 100 times the area of the unit square. That is the area of the unit square. That is the unit square. So meaning to say, I'm going to calculate how many boxes within the region that I'm talking about, this part. How many boxes are we going to have within this region? So there we've got 100. Remember, each complete box like this, it has got 100 small boxes. So there's no need for us to count those. We know that. So that is another 100, another 100, another 100. By just estimating here, we can see this is an approximate of 50 there. But you can count, you see that it's an approximate of 50. Then also count this part, the number of boxes that is you're going to have, depending with how this part here. Remember, this is the graph that you were having before, like it was affected. How many boxes? So according to the original part that I had approximately about 3 boxes there. This one is too big. So remember, our maximum value was at 6,25. 6,25, meaning to say some of these boxes are not even to be included. Remember, this is 6 and 6,25. Remember, each box is 2. So that is 6,2, then 5 somewhere there. So meaning to say we're going to have about 5 boxes taken there. Then maybe 6, around 6 boxes. So that is 100, 200, 300, 400, 500, and 50, and 56. Something like 556 boxes. So I do not know what are you obtaining, but that is approximately 556 over 100 times the area of the unit square. The unit square is the scale that you are given. 2 centimeters represents what? This box here. In the x-axis, 2 centimeters represent 1 unit. In the y-axis, 2 centimeters represent 2 units. So 1 times 2, that is a 2. So that is the area of the unit square, 1 times 2, which is 2 square units. So that was going to give us the area at the end. If you are to simplify this, that was going to give us the area at the end. That is the complete area of the given region. All right, so that was going to be something like, let me just try and simplify. 5.56 times 2 is going to be something like 11.12 square units. So you can even write in words square units. So it's going to be again an estimate. You're not going to have like the exact area, but something approximately, I do not know, according to the number of boxes that you were having from that part. So that was our part of the question, which is question 7, the quadratic graph, which is a parabola. And another thing is that when you are in exam, don't expect to be given a parabola, which is a quadratic function, a cubic function at the same time, an inverse function at the same time. Once you are given a quadratic function, like what you can, like this part, you are given a quadratic function there. Don't expect a cubic function on that case. Don't even expect an inverse function. They're done. Even a question under trivial graphs, don't even expect it. It is all covered up by this one question. So as you are revising, revise these questions wisely. The moment you just say, I'm revising a quadratic graph, you are revising a cubic, you are revising an inverse function, you are revising trivial graphs. What am I talking about? I'm talking about the velocity time graph and the distance time graph. You are revising them at the same time. The solving triangles at the same time. That is how the questions might be. All right. So then 8A, this is a mensuration of solid shapes. We are given the diagram shows a solid right cone with the base radius of 8 centimeters. So you've got the radius and also the perpendicular height of 15 centimeters. In this question, meaning to say every part of this question, take pi to be 22/7. Calculate the slant height of the cone. So this is the slant height of the cone. Remember, this is a right angle triangle that you're forming using the Pythagoras theorem. Remember that a squared plus b squared is equal to c squared, where a and b are the shorter sides, meaning to say the radius squared plus hypotenuse squared must be equal to L squared. So the radius squared and the hypotenuse and the this perpendicular height, that is 8 squared plus 15 squared, is equal to the slant height squared, which is representing the hypotenuse. So you can even introduce the square root. This is enough for you to give the answer there. So L is equal to the square root of this gives us the slant height, which is 17 centimeters. As you can see, this is 1 mark, and you'll be wondering, so I'm showing these because they know also you have got the Pythagorean triples. Knowing the 3, 4, 5 concept, these are Pythagorean triples, 6, 8, 10, the 8, 15, 17. These are some of the Pythagorean that you can use. If you know these Pythagorean triples, it reduces even these calculations. You can even just write an answer there. All right. So we have got the slant height there, 17 centimeters. All right. Then the volume of the cone. Remember the volume of a cone taking the concept of a pyramid. These they take the shape of the pyramids, and we understand that for the pyramids, the volume is given by a third of the base area times the height, which is the perpendicular height. So that is a third of the base area. What is on the base is a circle, area of a circle, that is pi r squared h. You're done. So that is a third times pi, 22/7 times radius squared. Our radius is 8. So that's 8 squared times the, that is the perpendicular height of 15. This is enough to present on your answering script there. Then from there, you write the answer. This is enough for you to obtain the 2 marks that you are seeing there. With this is enough. So that was going to give us 1005,714, something like that. Actually, as a fraction, it was going to be 7,040/7 cubic centimeters. This is volume. All right, if you were to write to 3SF, that is 1, 2, 3, it was going to be 1, 0, 1, 0 like this, cubic centimeters. Then you have to specify to 3SF. That is the 3 significant figures according to the instruction. Remember, they gave us an instruction there if the degree of accuracy is not specified. The curved surface area of the cone. So the curved surface area of a cone is taken from pi RL. All right, so remember your formulas also. The curved surface area is equal to pi RL. That is pi given as 22/7 times the radius, which is 8, times the slant height, which is 17. So that was going to give us 2992/7. All right, which is square centimeters. If you just want it as a decimal, it was going to be 427,429 and so on, which is 427 square centimeters to 3 significant figures. That is the idea there. All right, then after that, you are given the total surface area. So the total surface area is the sum of the cross-sectional area and the base area, which is the area of a circle. So that gives us the total surface area. So the total surface area, if you want the formula, it is pi r squared, which is the base area, plus the curved surface area, which is pi RL. So what we do not have is this area of a circle. The pi RL is the curved surface area, which is the one that you calculated here. So you're just going to have pi r squared 22/7 times radius squared, which is 8 squared, plus the pi RL already calculated this. We got 2992/7. That is to work with fractions, you obtain exact values. So that was going to give us the area, which is the total area that we have, and that was going to be 4400/7 as a fraction or as a decimal, 628,571, which is going to be 629 to 3SF, which is in square centimeters. All right, so that is with the degree of accuracy that you're given them. It was going to be square, it was going to be to 3SF according to the instruction. Each part that is not exact, we are given to 3 significant figures. Then on B, we are given a boy made several different objects. From modeling clay, he used 50 cubic centimeters of clay for each object, meaning to say he is using a volume of 50 cubic centimeters to make each object. Item 1, he made a square-based cuboid. A square-based, meaning to say on the base, it is a square where all the sides are the same, then taken to a certain height. So the question is that the height of this cuboid is given as 2 centimeters. Find the length of the side of the square base of the square base. This is a cuboid. How do you calculate the volume? Because you are given the volume in the first place. How do you calculate the volume of a cuboid? The volume of a cuboid is base area times the height. What is on the base? It's a square. Side is squared times height. So you can even ignore this to say side squared and calculate the base area. Then you use now the area of a square. But if you understand this is a square. So it's side squared times the height. So we are given the volume 50 is equal to side squared, which is the length of the square, times the height, which is from one square to another square that we are going to have. It's separated by 2 centimeters. This is the height. So what is the length of the square, which is S? So you can divide by 2 by 2. That is to solve for S. So S squared is equal to what? 2 into 50, that is 25. Then you're going to need the square root of 25 to remove the square. So S was going to be 5 centimeters. Remember, this is length. Length cannot be a negative. So you only consider the positive value. That is, they are testing you. Do you understand your formulas? the volume base area times height for a cuboid. The other part, he made a pyramid with the base area, or find the height of the pyramid. I talked about this, a pyramid. Just like what we saw on a cone. It's an example of a pyramid. The volume of each pyramid, that is a third of the base area times what? The height. So they are saying this pyramid that he made, it has a base area. So we are given the base area. So the volume of the object, the clay that we are given, the object, that is, it has got a volume of what? 50 cubic centimeters. With that volume of 50 cubic centimeters, what is going to be the height of the pyramid? So 50 is equal to a third of the base area, which we are given 15 times the height. So 50 is equal to a third of 15, that is 5. So we're going to have 5h, divide by 5, divide by 5 to find h. So h is what? 5 into 50, that is 10 centimeters. So this was going to be the height of the pyramid. From what we are given, this is the height of the pyramid. All right, from the same volume that we are given of 50 cubic centimeters, he made a sphere. Calculate the radius of the sphere given the volume. There they gave us a formula. You're supposed to know all this, but lucky enough, there they gave us the formula. So what is the radius? The volume of a sphere is given as 4/3 pi r cubed. We are given the volume. The volume is 50, remember. So 50 is equal to 4/3. We have pi 22/7. Remember, you're told to use pi as 22/7 times r cubed. So calculate r. How are you going to calculate for r? How are you going to calculate this value of r? So you can even multiply these together. That was going to give us 88/21 r cubed. So you can cross multiply, divide by 88. This is over. So you can even cross multiply 50 times 21. Then as you can see, there's 88, which is remaining. So you divide by that 88. So this will give us r cubed. And how do you determine r there? You introduce the cube root both sides. So r is going to be the cube root of this, which is the cube root of 525/44, if you were to simplify this, okay, which is something like 2,285, which is 2923 SF. That is how it can be like. They are simply testing you. Do you understand your formulas? Just the formula, only the formula. Do you understand the formula? Nothing much. It was an understanding of the formula, this question. Answer the whole of this question on a sheet of graph paper. They were given an instruction to take into consideration to answer this on a graph paper using a scale 2 centimeters to 2 units on both axes. In the ranges x from -8 to 10, then y from -10 to 6. All right, so that is what you're given, 2 centimeters, remember, to 2 units. So the x we are given, you're gonna consider that's 0 here, 2, 4, 6, 8, 10. Then we're gonna have also -2, -4, -6, -8. All right, then you can also consider -10. All right, -2 for the y values. -4, -6, -8, -10. You can also consider them -12. Okay. Then also for the positive values, 2, 4, 6, and so on. You can just consider up to 10, which is fine. All right, just like this. So they were given, that is your Cartesian plane. So this one was also a direct question because them were given triangle A with these coordinates, B with these coordinates. Draw and label these two triangles, A and B. Just mark the coordinates 2, 2, 4, 2, 4, 5. Guys, we talked about this. I think this is a direct part that you were given. So this is 2 versus 2, 4 versus 2, and also 4 versus 5. So 5 is in between 4 and 6, which is 1, 2, 3, 4, 5, somewhere there. All right, so that was gonna give us the triangle A. So this is triangle A, not triangle ABC, but just triangle A. Okay. This is triangle A, then triangle B with the coordinates -2, 4, and so on that were given. -2, 4, -4. It was -2 versus was a 3 there. That was a 3 in between. That's 1, 2, 3, 4, 5. That was a 3 there. Okay. Then the -2, 6, something like this. So again, you were going to join this part. You've got the triangle B. That's your triangle B. Just like that. So guys, transformation, I think that's one of the easiest part now from our introduction and so forth. Triangle A is mapped onto C by an enlargement. The center is 0, 0. The scale factor is -2. Draw and label triangle C. It's A onto C. The center is 0, 0. Remember, I talked about this matrix times object is equal to image. So that is the B part. All right. So already the center there, it's 0, 0. So I'm just going to do the calculations here, but you're supposed to do these calculations on your graph paper. Remember, they said the whole of this question on a graph paper, but just for the sake of revision. So remember that matrix times object is equal to image. If the center is considered at 0, 0, there are no adjustments, and the matrix for an enlargement is K00K. That is the Cook K00K, where K is the scale factor. The scale factor there is -2. So that's -2, 0, 0, -2 times the object, which is the triangle that you are mapping. You are mapping triangle A, and triangle A has got these coordinates, -2 versus 2, and so on. So you're going to take these coordinates 2 versus 2, 4 versus 2, 4 versus 5. Then row by column, matrix multiplication, row by column, this row by this column, -2, and at 2, that is going to be a -4. 0 times 2, that's a 0 there. -2 and 4, that is -8. 0 times 2, so as you can see, that's -8. Row by column, 0 and 2, that's a 0. -2 and 2, that is -4. 0 and 4, that is a 0 there. -2 and 2, -4, -10. So there, guys, multiply your matrix so properly. So that's our triangle C with coordinates -4, -4, -8, -4, and -8, -10. -8, -10. All right. So with these coordinates now, we are going to mark these on our graph. All right. That is -4 versus -4, somewhere there. -8 versus -4. -8 versus -10, which is somewhere there. Then we can join, thus completing our triangle C. So this is not triangle ABC. This is just triangle C. That is the idea of the question. So you must understand all the basics, guys. We talked about each transformation. Just go through your transformations, each part, so that you do understand. Then triangle D is the image of triangle. Again, we are still on triangle A, but this is a rotation 90 degrees about the point 2 - 2, which is the center. Remember the properties of a rotation. There's a center. Draw and label triangle D. So again, we can use our matrix method, but this time, remember, if you're given the center, the first thing is to subtract the center from the coordinates of the object, which is our triangle A. So this part as it was, we're just going to repeat this matrix of triangle A as it was. Well, let me just do it here. Let me just present this. Remember, this was our triangle A, this one. This is our triangle A. But now, to use the concept of matrix times object, we are limited because of the center. So the first thing is to subtract the center. There's a center of 2 minus 2. So subtract the center first. So you subtract the center, 2 minus 2. That is a 0 there. 4 minus 2. 4 minus 2. 2 minus minus 2. That's plus, which is 4. 2 minus minus 2. 4 minus minus 2. That's a 7. You're adding minus, minus, and minus. So there we need the matrix now so that we can use the concept of matrix times the object. And 90 degrees rotation, guys, I talked about the matrices. Remember, 90 degrees rotation. If you rotate 1, 0, it will end up at 0, minus 1. If you rotate this 0, 1, it will end up at 1, 0. So this is the matrix that you are going to use. That is 0, minus 1, 1, 0. Then multiplying row by column along the row, column 0 times, as you can see, 0 is going to multiply everything on top. 1 will multiply these numbers. So that's 1 times 4, which is 4. 1 times 4, 1 times 7. All right. Row by column, minus 1 is multiplying the top, 0 is multiplying these numbers down. So that's minus 1 times 0, minus 1 times 2, minus 1 times 2. We add back the center that we subtracted. Remember the stages. You subtract the center, you add back that center that you subtracted, 2 minus 2. So by adding the center, you are now obtaining the coordinates of the image. 4 plus 2, which is 6. 4 plus 2, which is 6. 7 plus 2, the 0 and minus 2. Minus 2 plus minus 2. Minus 2 plus minus 2, which is minus 4. So this gives us the coordinates of the triangle D that we need, which is our triangle D has got the coordinates 6 versus minus 2, 6 versus minus 4, and 9 versus minus 4. So these are the coordinates now that you are going to have. So there we have got 9 versus minus 4. So with the coordinates that we have, we are going to mark our points on the graph. Okay, so that is our triangle D. Like I said, there we have got 6 versus minus 2. Then we've got 6 versus minus 4. Then we also had 9 versus minus 4. 9, that's somewhere there in between 1, 2, 3, 4, 5. That's where we're going to have our point, 9 versus minus 4. All right, so that is join the points. You are forming the triangle D, which is the image of triangle A. So that was going to be our triangle D from the information that we had, the type of transformation that we are given there. That is a transformation, guys. That is your transformation. Then the other part that you are given, it was all right, let's see. That is D, describe fully the single transformation that maps A onto B, triangle A onto B. Remember, on your transformations, you're gonna consider the type. A and B, these are isometries, and I talked about having isometries. You can join the corresponding points. That is to make sure you can note the type of transformation that you are given. So joining corresponding points, you are going to see that these points, these first 2 points, they are maintaining same distance. They will never meet. The last 2 lines, I mean, the lines that you are having, these lines, they are maintaining same distance. They will never meet. These lines here, they will never meet. They are parallel to each other. Are they of same distance? Measure the distances. You're going to see that they are of same distance. So that means you're talking about a translation. Remember, a translation under the isometries, it is the one that you consider where you join the lines and they produce parallels of what? Of equal length. So this is going to be a translation. It is a translation. So remember, on a translation, again, you need the translation vector, which we say the translation vector is the movement, or you can take from the image minus the object. Just take any of the corresponding points from the image. Remember, it's A onto B. So B is the image and A is the object. Again, I referred about the distance that you can just move the distance. From this point, you can move horizontally straight. From this point, horizontally straight, then up to this point. How many units? -2, -4, -6. Going up, how many units according to scale? 1. So that is -6, 1. You can just take this according to the move. It's a movement. Or you can consider points, subtract the points of the image, with points corresponding to each other, image minus object. This point here is the image, -2 versus 6. Minus here, it corresponds to 4 versus what? 4 versus 5. Subtract. -2 minus 4, that is -6. 6 minus 5, that is a 1. So we have got same vector. Image minus object. That's the translation vector. Okay, so that was the part of your transformation. The matrix 1, 0, 0, -2 represents the transformation that maps A onto E. We do not even have that E, and we are not even asked to draw it. The question is, describe fully the single transformation represented by the matrix, this matrix here. Which transformation represents this matrix? If you understand your transformations, each 1, 1, 1 by each matrix, you see that this matrix is the same matrix that I talked about, or that I referred about, on a one-way stretch from the look. This is from one-way stretch. X-axis invariant stretch factor K. That's a one-way stretch. So it is a one-way stretch. That is a one-way stretch. X-axis, the x-axis is not moving. So that is x-axis invariant. And what is the stretch factor? Stretch factor, we are already given. From this format, our stretch factor is -2, which is K. So stretch factor, that is -2. The part that is representing or represented by what? By K. The part represented by K, that is the stretch factor. So you can even use the H from this one of a two-way stretch. Remember, the two-way stretch is the hook, like this. So if you put a 1 here, it's a one-way stretch. X-axis invariant, this is the stretch factor. If you put a 1 here, it's a one-way stretch. Y-axis invariant, this is your stretch factor. So just remember the hook, which is the two-way stretch, the hook. Okay, so guys, they want you to describe a matrix. Do you know your matrices? Of transformation, not normal matrices, a matrix of a transformation. Do you understand each matrix? So you need to know each matrix from a reflection. Because they might ask you to describe a matrix of a reflection. Not a transformation, but a matrix that you're seeing. This is a matrix that I'm giving, and they want you to describe that. Are you able to do that? All right. Question number 10, we are given, that is the matrices, that is find A and B. Remember, guys, your matrices addition. We just gonna add corresponding elements. That is A plus B. Our A is minus 3, 4, minus a half, 2, plus B, which is minus 2, 2, 6, 1. So you're gonna add corresponding elements, the minus 3 to minus 2, which is minus 5, 4 and 2, that is 6, minus a half plus 6. This is your calculator. Add, use your calculator. Don't be afraid to use your calculator. That's 11 over 2, or 5,5 as a fraction. 1 plus this 2, that will be a 3. Just like that, you're done. Okay, the inverse of A, that is A to the power of minus 1. So that is the inverse of A. Remember the inverse, you need the determinant first. So the determinant of A being the product of the major diagonal minus the product of what is in the minor diagonal. Major diagonal, there is minus 3 and 2, minus the minor diagonal, which is 4 times minus a half. So that was going to give us the determinant, which is going to give us minus 4. That's minus 6. Minus 2, which is minus 4. With the determinant, therefore, the inverse of A is 1 over the determinant, 1 over minus 4. So it's simply minus 1 over 4 into the major diagonal. You interchange these. So that will be 2 minus 3. The minor diagonal, you multiply by a negative. So if you multiply by a negative, this will be minus 4. Minus, that will be a plus 1 over 2. So that is the determinant. That is the inverse at the end. All right. Then the determinant of this matrix is 14. Find the possible values of K. If the determinant is 14, how do you determine the determinant? How are you determining the determinant? Knowing that the determinant is the product of the major diagonal minus that of the minor, you're going to multiply 3K into K minus 1, minus 4 and 1. We must have the determinant that we are given of a 14. Just formulate an equation. That's it, 3 times K, 3K times K, that will be 3K squared minus 3K. 4 times 1, which is minus 4, is equal to 14 transpose this. That will be 14 to the side. That is minus 14 to this side. That will be minus 18. You can divide by 3, which is the highest common factor of this. That will be K squared minus K minus 6 is equal to 0. Using our factorization, we can consider that we've got factors in this case. So just consider 2 brackets. That is the factors of minus 6. What are the factors of minus 6? But these factors of minus 6 should add up to minus 1, or must add up to minus 1. The products of minus 6. 2 numbers that you multiply obtain minus 6. Minus 3 and 2, 3 and minus 2, minus 6 and 1, 6 and minus 1. But which part, when you add, you must obtain a minus 1. So if you add this, you're going to obtain minus 1. That's minus 3 plus 2. So each bracket must be equal to 0. So that means K will be equal to a positive 3. This 2 to the other side, K is going to be equal to minus 2. So these are the 2 possible values of K that we are going to have at the end. Then circle geometry, we are given, in this case, this is C in the diagram, the circumference of a circle, center O. Then we have got the diameter. PS is the diameter. Remember, a diameter subtends an angle of 90 degrees at the circumference. So we are given this angle being 43 degrees, that is 68 degrees here, and so on. All right, so let's see. Find PSR. That is the first part. PSR, that is from P to S to R, this angle here. Remember, this is a right angle triangle, or just considering angles in a triangle, they will add up to 180 degrees. So if you simply, you can just subtract 90 minus 43, okay? Or this is 180 minus 90 plus 43 degrees. So that was gonna be 47 degrees. So this is the angle PSR, which is gonna be 47 degrees. PRQ, from P to R to Q, this angle that we are having here. Remember, this is the angle at the circumference. Consider this chord PQ. This chord, it subtends the angle at the center, or it also subtends angle R at the circumference. So R is half of this angle at the center. So just divide 68 divided by 2, which is 34 degrees. So that was gonna be at 34 degrees. All right, then PTQ. PTQ, from P to T to Q, that is this angle here. All right, so what can we consider here? There are so many ways. Remember, there we have got a radius from O to Q, that's a radius, and a tangent. A radius and a tangent, they meet at 90 degrees. So a radius and a tangent, they meet at 90 degrees. So this angle is 90 degrees. So considering this is a triangle, TOQ is a triangle like that. So angles in a triangle add up to 180. So you're gonna subtract 90 and 68 from 180, or just 90 minus 68 because it's a right angle triangle. So that was gonna give us the angle of 1T of PTQ. That is, we subtract 90 and 68 degrees. They are part of the triangle. So that was gonna give us 22 degrees, or like I said, simply 90 minus 28. That was gonna be 22 degrees. Just like that. Then another part that we are given, it was to calculate R, angle RQO, that is RQO, from R to Q to O, this angle here, RQO. Okay, there are so many ways that you can calculate this angle RQO. You can consider that these are vertically opposite angles. Vertically opposite angles, this angle and this angle here, they are equal from the concept of what? Lines intersecting. So there is an angle of 43 degrees, an angle of 68 from 180. We can have the remaining of the angle inside of the triangle. So that was gonna be 180 degrees minus 43 plus 68 degrees. And that was gonna give us 77 degrees, meaning to say this angle is 77 degrees, same as this one, 77. They are vertical opposite. So we can calculate this angle because there is already a 34 degrees. So the angle Q that we want is gonna be 180 degrees minus the 77 and the 34 inside of the triangle. So this was going to give us 69 degrees. Actually, there were so many ways to answer this question, so I don't know which way can you consider. You can just talk, comment about that and see if it can help someone. Your method can help someone. Just consider your method. You must have same answers at the end. That is the beauty part of it. All right, question number 11, we were given, that's a vector. Consider this vector A and so forth. Then we are given the ratio AX as to XB 2 as to 3. That means the whole of AB is 5 units, or the whole of BA is 5 units according to the ratio, not according to vectors, but according to ratio. So calculate or express in terms of A and B vector AB. So that is item 1. Remember, the vector of AB is the route that you're going to take from A to B. We can consider A O, then O to B. That is A to O plus OB. From A to O, you are opposing the vector. So that is minus A. O to B, you are maintaining the vector. That's a plus B. So that's it. You've got your vector AB. Then vector BX. According to the ratio BX, it is 3 units. That is our BX. So it follows that BX is supposed to be equal to 3 units out of 5 units of BA. Remember, you're moving from B to X. So you move from B to A. Vector direction is important. So it's 3 over 5 of BA. 3 over 5 of BA. But we do not have BA, we have got AB. So how do we write in terms of AB? We introduce a negative. So it is going to be minus 3 over 5 of the opposite vector, which is AB. These two will be equal if you introduce a negative and interchange what you are given there. So it was going to be minus 3 over 5 of vector AB, which is minus 3 over 5 into minus A plus B. You can expand the brackets if you want. That is minus 3 over 5 times minus. That will be positive 3 over 5A. Minus 3 over 5 times B. That will be minus 3 over 5 vector B. So this is our vector BX. That's our vector BX. Then vector OX, from O to X. Since we have got vector BX, OX is just a continuation because we can just move OB plus BX, just like that. Okay, so it's just a continuation to find OX. Okay, so that is from O to X, we're gonna move from O to B, then from B to X. We have got OB already on our diagram, that is vector B plus BX. BX, we calculated this vector BX, that is 3 over 5 vector A minus 3 over 5 vector B. Considering the like terms, so you're going to take the vector A, that is 3 over 5 vector A, then the vector B, this is 1 minus 3 over 5. On your calculator, 1 minus 3 over 5 is 2 over 5. So that's 2 over 5 vector B. So we have got vector OX there. Just like that. Then item B, we are given that if BC is equal to KOA, that is BC is equal to K times vector OA, which is O to A, it's vector A. That is vector A. So it's just vector A like that. Remember, we are told these two, they are parallel. So meaning to say, this vector BC here is given as K vector A, that is KOA. That's BC. So from the BC that we are given, which is KOA or whatever that you are given, that situation, that part, the question is, express AC in terms of this AC. So how can you find AC from this condition? If you are given that BC is KA, how can we find AC? So you're going to see that the part of AC that will consist of the KA is from A to B, BC. You're done. So using this route, you're going to have from A to B, then from B to C. From A to B, remember you calculated this vector before. That was the first part that you had, which was minus A plus B. So minus A plus vector B plus vector BC, which is our vector BC is KA. So that is our part. We can consider the part of A. There is vector A, there is vector A. So taking these terms of vector A together, you are going to see that you can even factor out the vector A. Factoring out vector A will give us a -1, and here we're going to remain with a plus K, plus vector B. So this is just to write our vector AC in simplest form. So that's -1 plus K, or K -1, vector A. It's up to you the way that you want to present there, but just one and the same thing. Just like that. It's a continuation that you're given from KA that you're having there. All right, anyways, that was it. OC is given. Express OC in terms of K, A again. OC in terms of K. So in order for you to have OC in terms of A, you must have the root from O to C. From O to C. So which root are you going to take? That is the question. All right, OX, let me see. OX, we're gonna need it. BX, we're not gonna need this BX here. So I'm just gonna remove this part. I think we're gonna use this BX, guys. All right. So this is item C. How can we find OC? But in terms of K, so in terms of K, for us to have vector OC, we must include vector BC because it is the one that consists of K. So that's OB plus BC. Just like that. So that's our vector OC. OB, that is vector B, plus vector BC. Our vector BC is KA. So that is it. That's our vector OC, which you can just write as KA plus vector B. Okay, so that's our vector OC. Just leave it like that. Let's move on to another part. Another OC was to be calculated given also that's another OC is OX. Express OC in terms of, this time in terms of H. So OC is equal to K OX. We have OX already here. We calculated OX before. So they are saying OC is equal to H OX. So that is H times OX. You multiply everything on H by H. H times this, that is going to be 3 over 5 HA, 2 over 5 HB. So that is our vector OC. In terms of what? In terms of H, vector A and vector B. Hence, find the values of H, K, and H. Hence, it's a continuation from what we have. Hence, so how do you find the values of H and K? You have to find or determine, you have to look for the two vectors which are the same. Are there two vectors which are the same? There is vector OC, there is vector OC. They are the same. So you can take advantage of these two vectors, the vector OC and the vector OC that you are given here. They are the same. So if they're the same, remember what I said, that from the two vectors, it follows that the part of vector A is equal to the part of vector A. So it follows that from this part, KA is equal to 3 over 5 of HA. These two are the same. So vector A and vector A can cancel. So K is equal to 3 over 5H. Consider the part of vector B. There's vector B, there's vector B here. So it means vector B is equal to 2 over 5 H vector B. Vector B and vector B are the same, so they cancel. You remain with what here? There is a 1. So it follows that 1 is equal to 2 over 5H. These are simultaneous equations, which is true. Which is very true. But look at this equation here, this part. There is one unknown. You can solve this. You can solve for H. Cross multiply this and that. You're going to solve for H. 5 times 1, that is 5, is equal to 2H. You can divide by 2. So H is equal to 5 over 2. With the value of H, you can even substitute it here in place of H to find K, because already K is the subject. So that is 3 over 5 times h. The h that we calculated, that's 5 over 2. So you can substitute there, cancel the 5 and the 5. So k is equal to what? That's 1. 3 times 1, which is 3. 1 times 2, which is 2. So there we've got the value of k. So this is the value of h and the value of k, which satisfies the given condition that you were having there. And from this, express AC in terms of A and B. Express AC in terms of A and B. We have AC before that we calculated. Remember here, we calculated AC before. It was in terms of K, A, and B. So they want you to remove K, you remain with A and B. But you do not just remove the K. You must substitute where there is a K with its equivalent value. K is equal to what? 3 over 2. So I'm going to substitute in vector AC. This is our vector AC here. We are going to substitute where there is K, we are going to substitute the 3 over 2 that we calculated there. So that was going to give us the vector AC in terms of A and B only. So this is minus 1 plus K. Remember our K was 3 over 2. That's vector A plus vector B. So minus 1 plus 3 over 2 was going to give us 1 over 2 vector A plus vector B. So thus our answer is in terms of A and B only. We substituted the constant that we had. The constant, we have got the equivalent of that constant. So that was our vector, 12 marks. So meaning to say, you must revise your vectors, like the basics of your vectors actually. All right, then question number 12, you were given in this case, this is bearing, solving triangles at the same time. So you are given in this case, this is the diagram. We are given these are points which on horizontal ground, an angle of 35 degrees, 85 degrees inside of the triangle, the 250 degrees, which is the bearing of Z from X. Then the dimension 7,2, 6,5. Calculate YZ. The distance from Y to Z, this has nothing to do with the bearing. This has nothing to do with the bearing. Don't include bearing where it's not involved. This is solving triangles. So they combine bearing and solving triangles. So this one is a solving triangle question. How do you find the length of a non-right angle triangle given two sides like what we have and an included angle, an angle in between the sides is called an included angle? How do you find this? Remember your cosine rule. A squared is equal to B squared plus C squared minus 2BC, the cosine of A, where A is the included angle. So that's YZ squared is equal to the shorter side squared, that is 6,5 squared plus 7,2 squared minus 2BC. You multiply the product of 6,5, 7,2, the cos of the angle that we are given, which is the cos of 85 degrees. So that's why Z squared is equal to what? So if you were to simplify this part alone, the first part of the addition of the two, that was gonna be 94,09 minus the product of these two, that was 93,6 cos 85. This is enough even to simplify direct on your calculator everything. That was gonna be 85,932. You write everything up to the end, then introduce the square root since you're given the square there. So the square root of YZ squared gives us YZ, which is gonna be 9,2699, which is 27 meters to 3 SF, 3 significant figures. So that means this was gonna be 9,27 meters. Then calculate XYZ. That is the angle XY to Z. That is XY to Z. This is the angle here. How can you calculate the angle? Again, this is solving triangle. Forget about bearing, guys. You are given an angle corresponding side. The angle that you want to calculate, it has a corresponding side. I said it is best that you use the sine rule when it is like this. The sine rule to calculate the angle. It is best that you have sine of A over A is equal to the sine of B over B. The sine of the angle to be calculated, which is angle Y, or you can consider the way that it was given there, XYZ, angle XYZ, over its corresponding side, 7,2, is equal to the sine, the angle which is complete, and its side corresponding, these two, they are complete. That is 85 over what? 9,27. You can use the values that you calculated before. So to remove 7,2 here is dividing, multiply by it, both sides, multiply by 7,2. That's to remove. You're gonna have sine XYZ being equal to 7,2, the sine of 85 degrees over 9,27. So this is you guys and your calculator. Simplify the decimal part on your calculator was going to be 0,77374 and so on and so on. So to find the angle, it will be arc sine on this side. That is to find this angle, XYZ. You find arc sine, which is shift sine, depending with your calculator. Is it second function? Sine of this answer. Do not round off anything. Then you are going to obtain 50,697, something like that, which is 6912, something like that, which was going to be 50,7. Remember, angles to one decimal place, as we are given the instruction. The bearing of y of z from y correct to the nearest degree. The bearing of z from y, that is z from y. All right, z from y. This is what we are having. This is y here. So from y here, what is the bearing of z from y? We need this angle to z. Remember, we just calculated the whole of this angle inside, which is XYZ. We got 50,7. But to the nearest degree, to the nearest whole number, this will approximate to 51 degrees, which is the one that we are going to use on the bearing. There is 51 degrees inside of this triangle. The one that we are using for bearing. So how can we obtain the other angle? Because we need the whole of this angle. So far we have got this part of the angle, this one. This is the part of the angle that we have. So what is it that we are going to need? We are going to need this remainder part, this piece that is remaining here. With this piece that we are having, we add together. That is the bearing. You're done. That is the bearing of what we need there. So how are we going to have that piece that is remaining on that part? That is the question. So if you consider these are north poles, remember the north poles concept, these are parallel lines. The whole of this angle can be calculated, which is the sum 250 plus 85. From 360 degrees, we have got this angle that is remaining here. 360 degrees minus the sum of the 85 and 250 degrees was going to give us 25 degrees, which is this angle that is remaining here. But these lines, they are parallel. So it follows that the 25 degrees and the angle that we want to calculate here, this remaining angle, they are co-interior angles. They add up to 180. Remember, co-interior angles, C angles. So it's 180 minus 25 degrees, which was going to give us 155 degrees. So this angle outside of the shape, outside of the triangle, the angle, this one outside, it's 155. Together with the 51 combined, that is the bearing of Z from Y. Combined like this. That is the bearing of Z from Y. So you're going to add these two. So the bearing there of Z from Y was going to be the sum, the 155 degrees plus the 51 degrees. So this is the three-figure bearing, and that was going to be 206 degrees. That is the three-figure bearing. That is considering the three-figure bearing. All right, then the other part that we were given was the shortest distance from X to YZ. The shortest distance from X here to YZ. Remember, when you're doing construction, we talked about this. You constructed a perpendicular from a point to a line, which was at 90 degrees. That line that is at 90 degrees is called the shortest, it is the shortest distance that you have in a triangle. That is the shortest. It's at 90 degrees to the line. It meets the line at 90 degrees. Remember, you calculated this angle Y here. It was 50,7. The 51 is the one that we used on a bearing, because the bearing, we talk about three-figure bearing, so it must be whole numbers. You must be using whole numbers. On any other calculation, you must use the value that you had. It was 50,7. How do you calculate the area? I mean, sorry, how do you calculate the paper this side? According to our solving triangles, how can we calculate this? This is a right angle triangle. So this is the hypotenuse. And according to this angle, it is opposite. The opposite side, the opposite to the angle that we are given. So which part that uses the opposite and the hypotenuse at the same time? Pythagoras theorem. I mean, from our trigonometrical ratios, SOHCAHTOA concept. Which one that has got the opposite and hypotenuse? A sine. The sine of theta, which is the sine of the angle, is equal to the opposite, which is the side that you want to calculate. You can just call it x, over the hypotenuse, which is 6,5. So that was it. You can calculate this by cross multiplying 1 times x, that is x 6,5 times the sine of 50,7. So this was going to give us the shortest distance, which was going to be 5,02, 5,0233 like that, 029 and so on, which is 03, something like that, in meters. Remember our dimensions, they are in meters. So be careful how questions are given. So this is how you're supposed to have attempted this question, actually marking everything about our question paper. So do so to revise as much questions as you can. Prepare yourselves for the exams which are just ahead of time. Make sure that you have the basics of each and every topic, the basic, know at least the basics of the topic.